buggy? This not working. Come on. Come on. This should be fun. I'll just cut this out of here because don't need that here. Let's do that there. That's another reason why I did that one. So the testing grounds are here. Right. Which means that down here what we want is the clear buffer bit, shader program, that should just work. Yeah, all this should work. Oh, that's nice. Cool. So this all should work. As long as it compiles, it'll be fine. 2 succeeded, 0 failed, 0 up to date, and 0 skips, which means I should get a triangle. And I have a triangle. Yes! Awesome. Which means so there are a bunch of things going on here, right? Because you have the update, which updates things. Right. So where do things get a little bit strange, right? Because all of this stuff is use, find, draw, right? So this is where things get a little bit strange. Because you need to be able to have different kinds of things, right? So when you render, the okay, so we have the VAO. Okay. So there are a few different ways around this, right? Because we can essentially have different vertex shaders. Now, where the hell did my... oh, there it is. Because the order of operations are really important here, right? Because like technically speaking, we would have different ways of doing this. Different things happening with the draw arrays. And then draw points here currently bound VAO with current in use shader. So the shader program is what binds the shader program is here, right? And technically speaking, what you can do is you can have the render do things, right? So you could pass in a shader program and a VAO so that you can bind your own stuff, and then but you'd have to compile. Create shader, compile shader, yeah. Oh, but all of these could happen in an initialization state, right? Because you'd have to initialize all these things, right? So you would... Oh, how would you do that? Because one way of doing it is that you'd have an initializer, which would like load everything in. Like that's the whole point of init, is that you would load everything in, which means that you can have a coolant. But why? Right. Right. Okay. So, because essentially what's happening, so you're telling the graphics card to do a bunch of stuff. Okay. Which means you would have all of these things set up. And you can bind it to the program. This is yet another gluent, right? So one of the things that you could do, and all this would just be in the initialization, right? Which means you'd have one like the rectangle, right? Like let's say the rectangle. So you could have right, you'd have a rectangle struct. I'm gonna call this indirect. Alright. Because it'd be like its own kind of data type. You'd have a render rect. And in it you'd have different information. Right, you'd have the width and height, and the position. Right. I don't want like a fat stack of triangles either. Right. I mean, it's not terrible. Okay, one of the things that I could do. I mean, it's fine. I mean, technically, as long as I can draw a rectangle, it'll be fine. Like, I don't need a circle yet. Good job, love. Aww. Because render, what would the render do? Because render should set do I even need that? Because it is a lot of data. Because rendering is mostly data. And does, like, should that be a thing? What would the render be? Scene render for sorry, right? Is it an actual system or is it a scene system? And would there be multiple render systems? Right? Like, do you have like, is there a situation where you would have different renderers? Or would it really just be one renderer? Because the scenes would have to initialize from the bottom up, and they would also render from the bottom up. I mean, I guess there could be different kinds of renderers, like a full screen shader renderer, which means that the actual render system would be a little bit different, but that's also more of a thing on the actual scene itself. And I also don't want it to be a virtual function, not for rendering. That's like really bad. However, you could set the... It's like a big part of it is that you are adding a bunch of different data. Oh yeah, because how would you add all of the data? Right, because if you have more than one rectangle, say, they are all different. And you would have to build the array. You'd have to build the array to facilitate that. Alright. And the system would have to be different. Because what you want to do is you want to limit the number of draw calls. Alright. Alright. Because this is going to have to be, in essence, in here. Alright. It's going to have to be in here to some degree. Right. And you're probably going to have to pass in the shader program into there and the VAO into there. Right, because once I do all this, what should happen is that the frame rate's going to tank. Actually, not necessarily. Yeah. Yeah. Yeah, I went down to 50, 86. Pretty bad lag, spikes. 400, and for the most part it's pretty stable. The PC was just struggling, yeah, 47. 55, 45. 24. 800. And again, none of this really needs to happen all that much. I also guess that init needs to do things too. Render, okay. So that's not really a thing that needs to happen there. It needs to happen in inits. I mean, I guess I could separate this from a render rect into a render, because the render is going to have all the information. Yeah. So struct render struct a render struct, or I should do a renderable struct. And the component struct is here. Component struct. Oh, I don't need the struct there. Renderable, because I'll need to have the but that might be different every time. Because there's like different ways of handling it, right? Because I could write the shaders to do certain things. With like uniforms and things like that. And then uniforms buffers. Because I could do I'm playing too hard. Aww. Let's see. Because what I would want to do is have some kind of buffer or uniform that, like for rendering a rectangle, say, I want to have either a buffer or a uniform that will like the because I don't want the index 3 VP. This is the vertex position. is what this is doing. Something very specific, right? Because the points are here, right? And one thing that I could do is either have because I don't want to use the, because I want to have all of these be like separate. And I'd want to have like some kind of array of vec2s. Or even just vec4s, you know, position and height and width, right? Because I can do that. So, because if I had a oh boy, because if I had take some pills. Oh, you're gonna use the pain cruff on it. At least we know that works real well. Dribbling. Right on your knuckle. Oh. Oh, poor my love. No. Nobody is watching. I think I really should start. Yeah, I think the next stream that I do, I'm gonna have to promote it. But because I usually get at least like one person coming in if I promote it. I have to go on Reddit and stuff. I think having a few streams that I don't promote is a good. Yeah. But yeah, I'd want to have different because I'd want to have, like, I have the buffer and I need to be able to update said buffer, and I want it to algorithmically update. Oh, poor my love. Okay. And the main question is, where do I put it all? Like, what is the data structure that I want to have? Like, how do I want to be able to do it? Right. Because I'd want to have a class rect. Rendered rectangle. Okay. In here I would have rendered rectangle. Yeah. Because in here.
No, it's still gonna hurt. I don't know.
Oh. Rectangle plus this equals something like rect, and then you'd have 0, 0, 0, 0.0, and then 1.0, 1.0, something like that, maybe. And this should build a square. I mean, it'll still be a rectangle with the same aspect ratio. Yeah. Be doing stuff because reasons. Yeah. Right. Do something along these lines, maybe? So that I can... Because for every scene, I only want to do this once. Right? I want to draw the arrays one time. So how would I do that? Because also what happens when you have things that aren't just you know, things that aren't just rectangles. So we have like squares and circles and text and things like that. Right. You'd have to end up building, because it's the draw calls are bad. You want to limit them. So normally it would be just different layers, because you'd have like post-processing and a bunch of other things like that. And the way that you would pull that off is having there's like a bunch of different ways of handling that. Because with like the fragment shader and things like that, because we'd have, you know, the 2D stuff and the 3D stuff is very different. Because I don't really know how I would be doing that kind of difference. Like, how would I pull that off? Because I really only want one draw call per scene. I think that's the ideal. I mean, each scene might have multiple draw calls. Because reasons. for like post-processing and things like that, right? Let's do a little bit of research. Number of draw calls in a game. I can only think of which is to benchmark the application. Shader switching can be everything from very expensive to not so expensive. It depends on the driver and the state of the OpenGL state machine, so it's very unpredictable in that sense. Generally, you want to build your game for target hardware and optimize it for that one. And you can make assumptions that faster cards will run it better and slower cards worse. This is why there's a whole system around finding the optimal settings for games. Generally speaking, you do not want to do context switches or minimize them, which is why a general purpose shader for all or most drawing makes perfect sense. Ballpark figure around 2,000 calls per frame is reasonable and typical for modern 3D games. I would start to look into batching instancing if you expect to need an order of magnitude more calls. This is based on the simple fact that at 144 Hz, 20,000 calls, the CPU has about 0.3 microseconds to process each call, which is not a lot. And that is assuming nothing else is going on the CPU. 2,000 calls per frame. Term constant more related to the number of render passes, specifically so for deferred rendering. Here's a nice blog that goes over the render process of various games in detail. Doom graphics study. Let's take a look at Doom. How a frame is rendered. Looks in the scene system is right after Predator suit. Okay. Used in Rage. First step is make a texture update. A technique already present in EdTech 5. And now also in Doom. To give a very basic explanation, the idea is that a few huge textures, 16K x 8K in Doom, are allocated on the GPU memory, each of these being a collection of 128 by 128 tiles. All these tiles are supposed to represent the ideal set of actual textures at the good bitmap level, which will be needed by the pixel shader later to render the particular scene you're looking at. When the pixel shader reads from a virtual texture, it simply ends up reading from one of these 128 by 128 physical tiles. Okay. And then the depth buffer, 8K by 8K the unique, like, okay. Depth pre-pass. All opaque messages are now rendered, outputting just their depth information into a depth map. First the player's weapon, then static geometry, and finally dynamic geometry. Okay. Interesting. And then a velocity map. Possessed cable and player's weapons are rendered in depth map. The velocity per pixel is also calculated and written to another buffer to create velocity map. The position difference of each pixel between the previous and current frame. Okay, so the occlusion queries, clustered forward rendering of opaque objects, clustered camera frustrum, cluster list, specular, screen space ambient occlusion. That does a bunch of crap there, and then it does a bunch of stuff, and then does all the rendering. And then multi-sampling, anti-aliasing, bloom, film grain, bonus notes, depth of field. So I can afford quite a number of draw calls. So it might not be too terribly bad. Like all this might need to be in here. Let's see. Interesting. So the render, render, update struct, update list, or render list. There's the scene. Scene's down here, the render scene is down here. So each system would have its own thing, and the system would have to... Every render system would have to build a buffer of individual objects. You'd have to build the entire shader system and do that, which means that data-driven programming would be kind of necessary. So it would have to have its own set of stuff. Because the way that it would work is that as you go through here, what you would actually do is set up the buffers, right? You would set the buffers and then send that buffer over, which means that the render struct might actually be rather different. The render struct might have access to the because the render struct might have access to each of the buffers, right? Is there a way to find out how big the set is? Yeah, let's find out. No, I'm gonna heart this. So let's see, std set count. Returns the number of elements with the key. Number of elements with key that compares equivalent to key x. What? Huh? I don't like that. Set count function. Okay, STL. Set name count. Right. Contains unique elements only. Okay. std set size. Set size. STL. Returns the number of elements in the set container. Okay. So I could do that, right? So the render struct could have access to a bunch of different information. Because the render struct what exactly is going to need to be there? Also, the order in which I set these things up is also going to be important. Because what do I need to render? One thing that I'm going to need is the shader program, VAO, vertex buffer object. Do I actually need that though? Or it's just a buffer object. It doesn't necessarily need to be a vertex buffer object. I need to update the buffer every frame. And I can do that by going through. Yeah, I'd find the component and get all information from it. So, in all actuality, what it's going to look like So in all actuality, what's actually going to look like is because this is for each entity. Okay, you want to add because in the render in here, yeah, this is so I need to find same, yeah, in here, it's not just this. Oh, for entity and system entities, what's the renderer system gonna be? How is it going to do it? Right, because in here, what we need to do is we need to add entity info to buffer, then bind the buffer to shader program, and we also need to bind the buffer to shaders. And then we'd also need to because what we want to do Because at the very end, we'd make the draw call. Right, draw call, question mark. Right. Or the draw call might be here. The draw call might be here. Right. In one of these locations, the draw call is going to happen. Where does the draw call happen? Because you want to limit the number of draw calls. I mean, technically speaking, you can get away with a lot of draw calls. But it's switching the context that's bad. But we're only really going to have one context. Because we only have one window. I mean, I feel like I don't understand how you can even switch the contexts. And like, how do you switch the context? Unless you have multiple windows. You know what I mean? Because the whole point is right. Bloom is pretty interesting too, by the way. And the UI and all that stuff. The UI is going to be the top part. It's going to be the top scene. Usually, the UI is going to be the top scene. Particle lighting atlas. That's interesting. That's cool. There's like a lot of like post-processing effects and a lot of other stuff going on too. How do you switch? One instanced draw call. Impossible to actually draw everything with only one draw call. Maybe I should have asked how many draw calls are there per frame in a typical. Oh. So what usually makes draw calls expensive is the state change. Uniform updates are super cheap. The vertex bindings is super cheap. UBO bindings are not super great. So if I can do uniforms, right, if I can the render target, yeah, so if I can keep the render target the same as much as possible, and if I can keep the programs the same as much as possible, as long as I have the uniforms be a thing. Alright. What is a UBO? Oh, it's a uniform buffer object. Not that one. ROP. For text bindings, UBO bindings. Let's see. BenGL, UBO. Uniform buffer object. Oh god, make this dark mode. Uniform buffer object. Be used to share uniforms between different programs, as well as quickly change between sets of uniforms for the same program object. Buffer object that is used to provide storage for uniforms. The term uniform blocks refer to the GLSO language grouping of uniforms whose storage comes from buffer objects. Okay. Open GLROP. Render output units. A raster operations pipeline is hardware component in modern and one of the file steps in the rendering process. Pixel pipeline, take pixel. Okay. Okay. So the program, switching programs. Changing this program as infrequently as possible is going to be important. Because vertex bindings, super quick. Uniform updates are stupid fast. You can do like 10 million in a second. You can also change the render target 60,000 times per second. So as long as things are in uniforms, or I feel like buffer objects would be pretty fast and nice. Yeah, because it's 300,000 for. It's 300,000 for. Yeah, it's 300K for programs. So when should the due to update? That's the raw information. That's when it actually gets updated. Because in the render segment, that is when you have these things. But the actual draw calls themselves, it's fine if there's a lot. So we'd want each scene to have, we can do a lot of draw calls within the same scene, just as long as the like uniforms. We can update uniforms super easily. So we can do something like loop through a bunch of like positions and widths. So for each entity, like for each entity you can update the stuff. That also means that this render system might not necessarily be a thing. Where? Where's the question? I mean, I also feel like these should be defined elsewhere. There's actual functionality. So move to CPP. Come on. I also want to move all these, and because I can, to do P. Because I'm pretty sure, because like all these aren't, like these aren't templated or anything, so it doesn't actually matter. Alright. So the main thing that we really want to come up with so yeah. Like where's the information going? Because you might need to have, so every entity that has a renderable component, a component that needs to be rendered. How do you do that? And that's the question. And also within the context of this particular game engine. Like, where is it going to go? How do I want to set these up? Because I want as minimal work as possible. Like, what's also going to be the whole purpose of this whole thing, right? Like, how many of these do I want to set up, and how much extra work do I want to do? Because it might be better to just not even have the whole, right? Like it might be better to just remove that altogether. At which point you wouldn't even have this, because it'll all be in the, because then it'll all be in the shader. The shader is going to be the one that's going to be doing all the work. And for the most part, all that you'd want to do is add the entities to, and the entity info to the buffer. And then once all that's done, you would bind buffer to program, and then you would run the, and then you would, huh? At like 3. Yeah, here soon. Yeah, because I think, yeah, I work tomorrow. Because I think here you would have that. And then here you do that. And the signature. Because you could have multiple different ones. And how much of you'd be doing that, right? Let's go back to the CPP. Go in here, you'd scene stack render. And this is in the main loop. Right. So I can do a pragma region render loop. Pragma and region. Alright. So that is mainly where all of this is going to go. Which means that I would have to go into scene render and set all of that up. Because the draw call will be in here. This could be for each individual system. Because the systems don't, because there's unlikely going to be a massive number of different systems that are going to be rendering. And there may even be like a scene system or a scene component for things like rendering, like full screen rendering and things like that might be a thing. Well, I mean, that's just a system, because the system's global. Because the scenes are just going to have entities that have renderable components. So the scene itself, it's gonna have to have the signature and the entities, and then whenever you call render, right, the render struct, it'll have like the render list. Alright, this is the list of systems that do renders. You would go into the render scene dot render. Then for each individual system, right? And then for instance, you would say if there's nothing in there, alright, sys dot entities dot size is equal to 0, then continue, right? This way, this way, do the render if unnecessary, right? Because if there are no entities to render, then don't even bother going through all the hassle of updating everything and doing a draw call and all this other crap, right? So you just end up skipping the draw call altogether. If there's no entities to render, then don't even do a draw call. So for each of these, you want to add the entity info to the buffer, then you bind the buffer to the program, and then you run the draw call, right? Which means that the render struct is not only going to have the signature, but you're also going to have the information because I don't want there, because how would you initialize everything, right? So I'm going to have the program. At the very least, I'm going to have the program. I could have... yeah, geobind vertex array. Because I need to learn more about the buffers, OpenGL buffers, buffer objects, and the buffer data. It's not necessarily a vertex, not necessarily vertices that I'm passing information in. Although technically speaking, this is kind of semantics. So I would be setting in all of the information for all that. Alright, well, I'm gonna end the stream here. It looks like I need to do some more research into OpenGL. My wheelhouse is just the shader programming itself. I don't have much experience in the full OpenGL context, because usually what I do is I just write the vertex shader and a vertex shader that spits out a singular triangle, and then just have the individual, and then just have the what is it, the fragment shader do all the actual work. I feel like I could probably do something along those lines as well, with different buffers and things like that. But I feel like that's not super great. Because the amount of information you would need for certain kinds of things is insane. Because you'd have to have like spatial, you'd have to create your own data structures for like spatial optimization and things like that. So it's like it is technically possible to do something along those lines, but I'm also not entirely sure how reasonable it would be to do something along those lines. Like, it's more than doable. It's super possible. It's not even all that hard. I'm gonna end the stream here and just figure out how I want to structure everything. So yeah, and I guess I should be saying I'm gonna end the video here because nobody watched the stream. Cool.